Now let us discuss another numerical problem in engineering mechanics. It is from coplanar concurrent forces. Concurrent means passing through the same point. Now let us understand the problem. This is a string A, C, E, D, B. On the string A, C, E, D, B are hung three equal weights. This string A, C, E, D, B, from this point a weight is hanging, from this point another weight is hanging, from this point another weight W is hanging. Three the weights are equal. W means mg. Instead of writing mg, it is replaced by W, the weight, right? Placed symmetrically with respect to the vertical line. The diagram is not slightly correct. These three are placed symmetrically. For example, you look at this diagram. How they are symmetrical. Look, this is the vertical line. From this point to this point is equal to this point to this point. Now, this point and this point, the midpoint is this. So this point E is the midpoint of the string from CED. E is the midpoint of the part of the string from C to D, like this. So they are placed symmetrically, right? Now, through the midpoint E as shown. Find the angle beta. Find this angle beta. It is given this angle is 60, also this angle is 60. So let us analyze. Now, on this part of the string, let the tension is T1. This part of the string, let the tension is equal to T2. Tension is a force along the string. This part of the string, tension is T3. This part of the string, the tension is T4. Now, look at this point. Look at this point. This point and compare it here. From point E, the weight is hanging downward. From point E, weight is hanging downward. And this tension I have taken it as T3. This angle is beta. So if T3, which is like this, if you break into two rectangular components, one component will be this, one component will be this. Means one component is like this, one is like this. This angle is beta, therefore this angle is also beta, which I have shown it here, beta. So this is your T3. So this will be your T3 cos beta, and this will be your T3 sin beta. Now look at this T2 is same thing as this T2. Now this T2 will have a component one like this and another like this. Since this is beta, this will also be beta, alternate angle. So this beta I have shown it here. So if this is T2, this will be your T2 cos beta, and this will be again, this will be T2 sin beta. And the whole system is in equilibrium, means the net force is 0. Now look, all these forces, this force and this force, they are passing through the same point, therefore it is called concurrent, right? Now let us look at the horizontal part. Sigma fx is equal to 0. Sum of the forces along x-axis is 0, to be in equilibrium. Now the x-axis is this. To this side is T3 cos beta, and to this side is T2 cos beta. Since this point is neither going to this side or to this side, neither it is going to right nor to left, therefore these two forces, this force and this force, must be equal. So T2 cos beta is equal to T3 cos beta, and cos beta cancels. So the conclusion is T2 is equal to T3. Means the tension in this string and the tension in this string are equal, right? Then look at this point is neither going up nor it is going down. So the upward force and the downward force must cancel each other. Now this point is same thing as this. Now here there are two forces. One is T2 sin beta, other is T3 sin beta. Both are upward and the weight is downward. So along the y-axis, this plus this should be equal to W. That is T2 sin beta plus T3 sin beta should be equal to W. Now T2 sine beta, I keep it like this. We have just proved T2 is equal to T3, means for T3 I can substitute T2. So for T3 I substitute T2 sine beta, so is W. T2 sine beta is twice T2 sine beta is equal to W. Therefore T2 is equal to 2 and sine beta comes to the right hand side. So T2 is equal to W over 2 sine beta, right? Now look at the point C. Now look at this point. Look at this point. At this point there are three forces, one this way, one this way, the other this way. Now you might ask, actually tension is a both way force. For this point, for this object, T2 is to this side. For this point, T2 is to this side. T2 is to this side. So this point C is same thing as this. This is your T1, this is your T1, this is your T2, same string, same tension, and this is your W, this is your W. Now this angle is 60. So if this is T1, one component is this, the other is this. If this angle is 60, then this angle will be also 60. That is what I have shown here. So this component will be your T1 cos 60, and this will be equal to, vertically what will be equal to T1 sin 60. Fine. Now again, this is your T2, this is your beta. Now this is your beta, so this will be equal to your T2 cos beta, and to this side it will be equal to your T2 sin beta. Now look at only the forces along x-axis. This is one force, this is another force. Since this point is neither moving to left or to right, therefore this must be equal to this. Therefore T2 cos beta is equal to T1 cos 60. So from this, your T2, we have just calculated T2 is equal to W over 2 sin beta. So for T2 I put W over 2 sin beta, this cos beta remains same, T1 cos 60 1 by 2. So these two cancels with this. So I am left with T1 is equal to W cos beta over a sin beta, right? Then in the vertical direction, along y direction, means this point neither going up nor coming down. So the downward force and the upward force must cancel each other. So the sigma Fy means sum of the forces along y axis, that is T1 sin 60 should be equal to W plus T2 sin beta, sin 60 is root 3 by 2, T1 W, T2 sin beta same remains same. So T1 is found out here, W cos beta over sin beta, root 3 by 2, this W same thing as this. Then T2, which was previously calculated as W over 2 sin beta. So for T2 I write W over 2 sin beta, this sin beta here, this sin beta cancels. Now W, this is cos beta over sin beta, root 3 over 2. Now W here taken common, so I am left with 1 plus 1 by 2, that is equal to 3 by 2. Now this W cancels with this, and these two cancel with this. So on the left side I am left with root 3 cos beta over sin beta, that is cot beta is equal to your 3, So cot beta is equal to root 3 goes to the other side, it becomes 3 over root 3. So I split this 3 as root 3 into root 3, root 3 cancels, so root 3. So in cotangent table, where do we come across the value root 3? At 30 degree. Therefore beta is equal to 30 degree. Therefore this diagram was rather correct. It is symmetrically drawn anyway. Thank you.